Hello, everyone. My name is Jun Namikawa, and my presentation is titled, How Does Line Implement Cross-Service Data Utilization? I am responsible for development related to machine learning. But today, I will not limit myself to machine learning, but give a wider introduction on how Line achieves data to be used across its services. Line offers various services in order to support its users throughout their daily lives. These services are connected on the Line Messenger platform, offering a comfortable and convenient user experience that individual services alone cannot provide. In order to offer these convenient services, Line engineers are involved in directly developing new services as well as focusing efforts on R&D for latest AI technology. However, equally important is making effective use of data. By connecting data that comes in from various services and applying analytics and optimization, we're able to recommend beneficial content and offer a smoother user experience. So I mentioned that we collect and utilize data. Just how much data is actually being generated on a daily basis at Line? Here are the numbers. Currently, we collect data from 53 services, which amounts to over 17,800 tables. More than 700 billion records are added every day. It is part of our daily job to collect, retain, and leverage these extensive data. Because we handle data at such a large scale, Line has its own DSE Center. DSE is short for Data Science and Engineering. I won't go into details, but this center encompasses the data management team making strategic decisions on how to utilize data, the data platform team who manages and operates Hadoop and Kubernetes clusters, data labs who performs analysis and handles machine learning, and the engineering infrastructure team in charge of the overall infrastructure. These teams work together to generate new value by effectively utilizing data while protecting user privacy. This shows the mission and goal of the DSE Center. If each services managed its own data in separate systems, that would naturally increase management costs and make it challenging to analyze and apply machine learning to gain insight across services. As such, our mission is to bring each service data into one data platform and offer a secure and uniform analytical environment where all services can access the same features. Furthermore, we make strategical decisions on utilizing data, as well as analyze and apply machine learning across services in order to gain deeper insight that cannot be achieved when data is handled separately. This is all for enhancing Line's user experience. This is today's agenda. First, I will touch on data platform and our machine learning platform. Aside from collecting service logs, we also create an attributed feature store so that machine learning can be applied in a more comprehensive way. Then I will introduce Crossdomain Recommendation, a machine learning application where we connect data from different services. Inferences based on other service usage history helps to better discover contents that users want. Today, I will share some examples of how we were able to enhance this system. The third topic is data analysis and data management. This includes the environment and tools our data science currently use and examples of service improvements that were achieved as a result of our analysis. While leveraging data is important, so is security and governance. I will wrap up by introducing what the data management team does in these areas. Let me start by introducing our data platform. Line's data platform is called IU, short for Information Universe. IU consists of several elements, including a distributed system in which we use the all-too-familiar Kubernetes and Hadoop. We also use distributed storage called Ceph. This is used to store images, audio, and video files in order to support machine learning for these contents. Then we have the computing framework. IU reads data from the storage and processes the data. When writing the data back to the storage, we use tools such as Spark, Hive, and Flink. Link is used for streaming processing, Spark is used for more general purposes, and Hive is selected when we want to use TES on SQL. This distributed framework is not only to process IU data, it also provides data to storages used by each service, or vice versa, where we collect data from the service side and save them into the system. And finally, we have business intelligence. In order for data scientists and planners to gain insight, or for machine learning engineers to develop models, we provide tools such as Tableau, Oasis, and Yanagishima. Details about these tools will be presented in a separate session featuring our data science activities and our analytical environment. As a data platform, I believe IU is quite extensive in scale. Currently, we have more than 2,500 servers. Storage size exceeds 270 petabytes with over 300K workloads a day. The DSE Center plays a crucial role in order to operate such large clusters in a stable manner. Next, let me explain the user features built on the IU. IU collects service logs and content data from the service database or through Kafka. These data are collected by streaming or by batch process. IU does both analysis and machine learning. For example, it analyzes last 1 year worth of data to discover seasonal factors or apply machine learning on data acquired by stream processing. Therefore, IU needs to handle both real-time data and retain past data for a prolonged period. Data that enters IU is shaped, where differences by services are absorbed, then stored into the feature store so that data can be utilized across services. At Line, we call this Z features. Because machine learning requires both user activity logs and content data, we save them in a format where these data can be used together. We also provide data converted to embedded vectors, which is more convenient for deep learning. And based on the nature of the task, machine learning may also utilize this format. Aggregated features are leveraged as inputs for tasks like content recommendation, classification, and CTR forecast, which is then reflected to each service. At this time, each service can also acquire results from machine learning that leverages data outside of its own services. This is a great benefit for a platform like Line that provides many services. As for how beneficial this is, I will explain in detail along with some case studies. These are the type of data that can be commonly used for machine learning. Data from various sources such as official account, timeline, open chat, ads, news, music, and manga are consolidated here, where they can be read in a common format and used for machine learning models. Here are some statistics on Z features. Currently, we have over 62 million feature dimensions and more than 900 million global users, which also includes inactive users. Dimensions and record numbers are immense. However, because we have a common specification, it is easy for Line's machine learning engineer to read the data and use it for its model. So up until now, I've spoken on data platform. Next, let me introduce a few examples on how data is optimized across services. Cross-domain recommendation is an example of leveraging data from one service and applying it to another service to enhance the precision of recommendations. Domain can actually be interpreted in different ways. However, to keep it simple, we can think of it as different item types. If we know what a user likes in a particular service, we will be able to leverage that information in other services to make recommendations. Line provides recommendations leveraging cross-service data in various places on its platform. For example, news and Line Live service logs are used to predict the type of post users may want to see on timeline. Sticker purchase history is used to recommend themes. If you're interested to know more about Timeline Discover and Themes recommendation, we have a separate session during this year's Dev Day. In my presentation, I would like to introduce the third use case, Smart Channel. Before doing so, let me give an overview of Smart Channel. Smart Channel is a service that displays various contents on the top part of the Line Chat tab. Because every user likes different services and information, it is necessary to display the right content at the right time. So we have a recommendation system running behind Smart Channel. Let me explain the recommendation system process and how content is delivered to the user. This is a chart that simplifies this process. Smart Channel actually adopts a two-stage recommendation system. In the first stage, recommendation system in each of the three services in the left here generates a list of recommendations for their respective services. Here, let's say Line News, Fortune Telling, and Sticker each created their own list of recommendations. Line News and Stickers actually have their own recommendation system, so we leverage their output. These recommendation lists are then sent to Smart Channel's recommendation system. This is the second stage. The CRS Engine in this recommendation system takes content from multiple recommendation lists and selects content to deliver to the user. Selected contents are displayed on the top of the chat tab. Then, based on feedback such as whether the user clicked on the banner or not, CRS Engine learns on what content to show to this particular user. Let me introduce 3 optimization features on how the CRS Engine selects content. First is user segment. Based on aggregated user activity logs that is collected by Z features, CSR takes inferred user attributes as features. Next is contextual bandits. Because Smart Channel aims to deliver updated information, most content is shown only for up to 24 hours. This means we must handle cold start issues when it is lacking insufficient data. To solve this issue, we adopt Bandit's algorithm, allowing us to maintain a good balance between exploring and selecting contents that user likes. And because it is up to each user whether they prefer a certain content, we adopt contextual bandits to optimize and reflect these differences by each user. Smart Channel requires near real-time optimization, so this area is done by online machine learning. And the third is cross-domain user and item embedding. When users see content from various services displayed on Smart Channel, they may tap on the banner or close it. In order to predict the action a user may take on the display content, we apply feature learning to users and items and leverage features from contextual bandits. This area is also done by online machine learning. With this, user and items vector representations are learned across various services, which means the results from transfer learning is easier to optimize.
Next, let me explain the effect of cross-domain optimization using an example, which is when we had distributed a new free sticker set through Smart Channel. We targeted all users in Japan. In the first trial, we did not apply cross-domain representation learning. In the second case, we did. Here were the results. This is how much the results differed between the first and second tests. Starting with impressions. This was the number of times the banner was shown to users. This increased 36 times. With the Smart Channel CRS Engine, contextual bandits help to show more content that users are more likely to enjoy. By applying cross-domain representation learning, we were able to quickly learn who would or wouldn't appreciate free stickers, and this increased the impression. Next, we have CTR. Although impressions increased, you can see that CTR also improved 40%. Lastly, the score. This is a ratio of clicks to mutes, which is also the comparison between positive and negative responses, but this also improved significantly. With an app like Line that has a lot of users and has a lot of services on its messaging platform, cross-domain machine learning helps to produce significant results. To repeat, with Smart Channel, cross-domain recommendation helps to produce significant results. Because we can start using cross-domain representation learning with the CRS Engine and we collected enough cross-service data, recently we've started to serve content ourselves without the service's recommendation system. This is the arrow extending from service D. By doing this, if a service already has its own mature recommendation system, it can continue to do as it has. With new services and new content types, they can be optimized based on the performance of other services. So that was machine learning. Next, I will talk about data analysis and data management. At Line, the Data Lab's data science team analyzes data for different services. There are 4 groups, and each group analyzes for a different service. But because they belong to the same team, they often share their analysis results so that the insight from one service can be applied to another. Let me tell you a bit about the tools that our data scientists use, starting with the BI tool. Do you know Oasis? You can use Spark, Python, R. You can create graphs. There's Yanagishima that can be used to quickly execute SQLs. Using these, you can easily access data on IU clusters. Engineers and planners also use these tools to check data every day. Next are analytics tools. Line Analytics is a tool that shows client logs in a graph so that you can quickly check service data. Next is A/B testing tools. There's a CMS called Libra that you can use to determine the, let's say, test schedule across different services, and the results are automatically computed in a Libra report. Using these tools, our data scientists are gaining insight every day. To explain more about data scientists, here are some examples. First, we had done analysis to renew our chat menu. We had done this to improve user experience, but because the chat menu is also connected to many services, changing this would impact a lot of different areas. So some, let's say, results might improve, but others might worsen, which means that analyzing and designing KPIs becomes very complicated. There's also new UI bias. Users tend to prefer a familiar UI, so changing the UI tends to produce negative results. So we need to determine if the change is a good change in the long term or a bad change. This is very difficult, and this is where data scientists can really show their skill. Next was an open score project for official accounts. Based on analysis results, we were able to determine that the more messages we send, the less they are opened. So we needed to find the right transmission frequency to maximize results. So these are the kinds of tasks that data scientists carry out every day. For these 2 examples, we have sessions in this year's Dev Day. Please check them out. Let me share some improvements that our data scientists helped to make. First was related to targeted messaging from an official account for our financial services. We wanted to distribute useful information related to our financial services through the OA, but as we found out with Open Score, just sending messages has an adverse effect, and this could be annoying for users. So we need to target specific users. In the beginning of this activity, people had to manually extract the rule and send the messages based on information such as the number of financial official accounts users follow and so on. But now, this is done through a feature called Lookalike. Here's what I mean. Let me explain first what the Lookalike audience targeting is. You have a control group called seed users, and the system would return similar users. That is the yellow module in this diagram, and the similar users are inferred and calculated. And what does it mean when a user is a lookalike? This is determined based on the behavioral pattern of users using different line services. Basically, up to 60 million dimensions of feature vectors are used to determine the similarity. So, a user that has used any of Line's services would be targeted. And then, you can target users who have used your service and even users who have not used your service yet. This is a comparison of manual targeting and lookalike targeting. And these are the actual messages we sent. The circles show the improved CTR and CVR as a result of lookalike targeting. As you can see, with lookalike targeting, the precision improved. Additionally, because we were able to automate targeting, data scientists can spend their time on other tasks. So, that was how we have been utilizing our data. But we also need to protect the safety and quality of our data. That brings me to my next topic, data management. First is the most important topic, security. Starting with the system, IU cluster authentication is done with LDAP and Kerberos. Authorization is done with Apache Ranger. And we're also collecting audit logs for auditing so that the data management team and information security team work together to create, let's say, guidance manuals and workshops for data use. Next is data catalogs. We need a way to determine the kinds of data that is contained in more than 17,000 tables, so we have a catalog for that. In this catalog, in addition to the column definitions, you have the source and owner of every data. Next is data governance. This determines who has access to which data and what kind of data use is permitted. Here's an example of the data catalog. In the columns of each table, you can see that there's an explanation of the kind of data and the source if it's an ETL, and everything is searchable. In the data management team, they answer all questions related to data. So there could be questions from service planners, engineers, data scientists, machine learning engineers, and so on. The questions could be related to security, privacy policies, or legal. They are the hub. That was a summary of Line's data use from perspectives including platform, machine learning, data analysis, and data management. Lastly, let me share with you our future work. We have been building a unified data platform called IU. So, we have been able to unify the use of different line service data. Now we want to unify the platform so that machine learning engineers, data scientists can produce results more quickly and conveniently. Here are the main components that makes this possible. First is Deep Pocket. This contains OCR, object detection, and other rather AI-related features through an API. This slide shows recognizing handwriting with OCR. By the way, this sponge creature was created by my son. And we added some handwriting, and this was recognized. With this MLU, we use Deep Pocket for API serving. Next is Zootopia. There are too many features to explain all of them. But basically, Jupyter is the core of this comprehensive environment. In addition to testing, modeling, deployment is all supported. We also have a session on Zootopia in this year's Dev Day. So, if you're interested in machine learning and development environments, please take a look. Next is Datagram. So, based on the premise that it will be connected to the IU cluster, this Kubernetes cluster was designed. So, we often run machine learning jobs on Kubernetes. And IU data is used by default. So we want to use Datagram for all of MLU's infrastructure. This is the last component, called Masala. It is a distributed processing library for machine learning. IU contains volumes of data, so machine learning engineers need to be able to use it efficiently. But if every machine learning engineer or researchers need to do parallel computing themselves, this is very costly. So we have created libraries for this to make this more convenient. To tell you more about the library, you can use frameworks such as TensorFlow and PyTorch. Furthermore, you can use ZeroMQ and MPI for efficient parallel computing. These are hidden so that you don't need to worry about these. We also have sessions in this year's Dev Day titled GI, so please take a look. Our challenge is to combine these kinds of components to develop a more convenient development environment to deliver convenient services to our users. Thank you for watching.